Hello children, welcome once again. As a part of revision for the public examinations, coming public examinations, you know that we're making some videos. So as a part of it, now we are going to deal with similar triangles, part 1. Still we have 2 or 3 more videos. So please watch and learn and earn marks in your public examination. Okay? Title of our chapter is Similar Triangles. Of course, similarity between two triangles. In fact, the entire chapter runs on the theme that similarity between two triangles and its several implications, several results obtained from this wonderful property. Anyway, my question is, when can we say that two triangles are similar? Of course, you might know by this time the conditions that we need to state that the two triangles are similar. Yes, first one is their corresponding angles must be equal. That means the angles that exist in one triangle must also be the same in the second triangle. So, three angles in the first triangle and three angles in the second triangle must be the same in measure. And the second condition is if their corresponding sides are in the same ratio, their corresponding sides must be in the same ratio. Suppose here AB's comparison or AB's corresponding side is PQ, then we take the ratio AB by PQ. And suppose BC's corresponding side is, BC's corresponding side is QR, then I will take the ratio BC over QR. And if CA's corresponding side is RP, then I'll take the ratio CA to RP. Then what should I notice is these ratios must be equal. Then I say that the sides are in the same ratio or the sides are in proportion. This is the second condition. So mere equality of the angles does not establish you the similarity, but these two conditions are vital to establish that two triangles are similar. Okay, so the question may be asked like this: when can you say that two triangles are similar? You can answer if their corresponding angles are equal and if their corresponding sides are in the same ratio. Okay, right, let's move. Let us quickly jump to one of the most important questions of this chapter, basic proportionality theorem. Of course, I made it as a separate video, so please watch that video. You can get it at the end of this session. So basic proportionality theorem is clearly explained and you can watch it and you can learn it easily, right? Thank you. Let us do some of the applications on basic proportionality theorem, Thales theorem. So one of the problems is like this. In triangle ABC, DE parallel to BC and AD by DB is equal to 3 by 5, AC is equal to 5.6 centimeters, find AE. Is the first example that was given in our textbook, right? Okay, let's take triangle ABC like this, and DE is parallel to BC. So whenever we see this kind of situation, we certainly remind Thales theorem. Okay, AD by DB is equal to 3 by 5. That means 3 is to 5. So this portion is divided in the ratio 3 is to 5. That's what we need to remember. So because of the Thales theorem, since this is parallel to BC, this side must be divided in the same ratio, 3 is to 5. So by Thales theorem, what can I conclude is, by Thales theorem, yes, AE by EC is equal to, I'm coming from that side, AE by EC is equal to AD by DB. AE by EC is equal to AD by DB. That is, AE by EC is equal to 3 over 5. That means AC is also divided in the ratio 3 is to 5, in fact by E. Therefore, what is the portion AE then? AE is being divided into 3 parts out of 8 parts. That's why, but given AC is equal to 5.6 centimeters for us, 5.6 centimeters. Therefore, let me tell you, AE is equal to, so 3 parts, 3 by total parts 8 into 5.6. So 8 sevens are 56, but here 5.6, so 3.7, 0.7 in fact, 0.7, 8 sevens 56, 8 0.7 is 5.6. So 3 0.7s is 2.1 centimeters. Likewise, you can find AE. So by Thales theorem, AE by EC is equal to AD by DV. Yes, AE by EC is equal to 3 by 5. That means AC is also divided in the ratio 3:5 by E, in fact. But AC is given 5.6. What is the portion that we need? AE. AE is equal to, like this. We can do this problem, right? Right. Another problem. In triangle ABC, DE parallel to BC, AD is equal to x, DB is equal to x minus 2, AE is equal to x plus 2, and EC is equal to x minus 1. Find the value of x. Okay. In the textbook, order of the vertices was given like this. You can see in the textbook, right? This time, see, DE is parallel to BC, this side. Okay, it can be in any direction, but this time, see, DE is parallel to BC. That means our perception must be in this direction, okay, right? What were given? AD is equal to x, AD is equal to x, and DB is equal to x minus 2. Note down here, x minus 2, and AE is equal to x plus 2, and this is x plus 2, and EC is x minus 1. After giving all these things, he is asking us to find what is x. Yes, I told you, you must see in this direction, triangle ABC. So if you see that by Thales theorem, since DE is parallel to BC, by Thales theorem we can write AD by DB. Here also AD by DB is equal to AE by EC. The same condition holds here. So x by x minus 2 is equal to x plus 2 by x minus 1. Okay, right. After this, some general procedure we have to follow. Cross multiply this, x into x minus 1. Okay, x into x minus 1. So let me write once again, right? X into x minus 1, this one and this one, like this, is equal to x minus 2 into x plus 2. Now x into x minus 1 is x square minus x, and this is like a minus b into a plus b formula. That's why x square minus 2 square, that means 4. Okay, x square gets cancelled, minus x is equal to minus 4, therefore x is equal to 4. Likewise, we can tell the answer. Okay, if what is the length of AB, sometimes he may extend the question like this. What is the length of AE, he may ask. What is AE? AE is nothing but x plus 2. That means 4 plus 2, that is 6 units, whatever it given. So if it asked for AB, you just add x plus x minus 2. Suppose AB is asked, you have to add x plus x minus 2. That means 4 plus 4 minus 2. That means it's also 6. Okay, it's also 6. Okay, you can answer such questions carefully observe them, and what is asked is reached or not important. That's what you have to observe. Okay, let's move further. Right, let's do one more important question. Prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Okay, have you observed the three phrases that were given? Right, let me take a triangle first, then you can understand easily. Suppose this is a triangle that we are looking for, ABC. And what happened? A line drawn through the midpoint of one side. Suppose I have taken midpoint of AB, this is D, and here I am going to draw a line draw through the midpoint of one side of a triangle parallel to another side. Suppose I have started from D and drawing parallel to BC, and this line goes and meet AC at a particular point. Suppose the point is E. Then what happens? This DE bisects the third side. That means this D goes, and where does it go? To the point exactly to the middle of AC. That means this AE and EC will also be equal. That means DE bisects AC. That's what we have to prove. So for this, how can we answer? Okay, in triangle ABC, D is the midpoint of AB. Therefore, AD is equal to DB. Okay, and DE parallel to BC. So since D is parallel to BC, therefore by Thales theorem, what can we conclude? If a line is parallel to another side, we have obtained a result that AD by DB is equal to AE by, the sides are in the same ratio. AD by DB is equal to AE by EC. But what do we have here? AD is equal to DB, because obviously D is the midpoint. AD and DB are same. So since AD and DB are same, we have equal quantities in both numerator and denominator. So we get 1. So 1 is equal to AE by EC. Since why it is 1? Because AD is equal to DB, and so we have ratio of AD to DB is 1. So bring this EC to here. EC is equal to AE. That's it. EC is equal to AE. Therefore, E is the midpoint, or you can say that DE bisects AC. Okay, right. Likewise, you can do this problem. Learn it, easy one. And another question of the same kind, what we have done earlier. Prove that a line joining the midpoints of any two sides of a triangle is parallel to the third side. Again, here we were given a hint, but we may not get in our examinations. Okay, let's try to understand this question by solving it. So let's take a triangle ABC. In this kind of triangle, suppose a line joining the midpoints of any two sides. Suppose I have taken midpoint of this AB and midpoint of this AD. So name it as D and name it as E. Suppose a line joining the midpoints of any two sides of a triangle. That means I'm going to join this D. Is parallel to the third side. That means we have considered these two sides, so this DE is parallel to BC. That's what we need to prove. Okay, so yes, what shall we do here? Okay, here see, D is the midpoint of AB. That means therefore AD is equal to DB, isn't it? AD is, since it's the midpoint in the middle, AD is equal to DB. In the same way, E is the midpoint of AC. Therefore, AE is equal to EC. Right? Since AD is equal to DB, that implies AD by DB is equal to 1, isn't it? Because both are equal. AD is equal to DB. Since we have numerator both denominator same, we get 1. AD is equal to DB, that implies 8. Or you can bring this DB this side. In the same manner, AE is equal to EC means AE by EC is equal to 1. So observe the ratio AD to DB and AE to EC. Both are equal. Therefore, AD by DB is equal to AE by EC. So the line DE is in such a way that AD by DB is equal to AE by EC. Therefore, since the ratios are same, since the two sides are divided in the same ratio, by the converse of the basic proportionality theorem, we can say that this happens only if D is parallel to BC. That's it. D is parallel to BC because AD by DB is equal to AE by EC. So the ratios are same. So DE must be parallel to BC. Okay, right. Let's move further. one more question. This is also an important question. Try to solve it. Say here AB, CD and PQ are perpendicular to BD. AB is equal to x, CD is equal to y and PQ is equal to z. Then prove that 1 by x is 1 by x plus 1 by y is equal to 1 by z. Okay, let me take it. This is AB and this is CD and this is PQ. Like this, these three lines are on a line BD, standing on a line BD. These are perpendicular to BD. So here again AB is equal to x given, CD is equal to y given, PQ is equal to z given. So we have to prove 1 by x plus 1 by y is equal to 1 by z. So let's try to prove it. Answer. So for this, I want to make you to think like this. Suppose let's take this side of this diagram. Yes, this is AB, this is D, and this is PQ here. And again, from this, I want to divide the two triangles that are appearing for me. That is, one is big triangle A, B, D, and small triangle inside it P, Q, D. Right? Okay. Now, what I want to establish is these two triangles are similar. That means the triangles that are appearing one in the other are similar to one another. But we should not state in such a vague way. We need to produce some evidence. So here, observe these two triangles. Now they have a common angle, and also they're standing on the same line BD. That's why they are nothing but altitudes. That means they are at right angles. So both have right angles. Automatically the third angle will be equal. So by A similarity, we can state A similarity. We cannot establish for congruency, but we can state for similarity. By A similarity, we can say that these two triangles are similar. So since these two triangles are similar, yes, let me write in a proper way. In triangles ABD and PQD, what I notice is by AA similarity, triangle ABD is similar to triangle PQD, isn't it? See, D is common to both, they have right angle, automatically third angle will be equal. So what happens? Okay, we were given this is x, this is z. What happens? Okay, let me take z by x. The sides are in the same ratio, or corresponding sides are in the same ratio. So this side must be corresponding to this side. So z by x is equal to I'm starting from the small triangle. Z by x is equal to QD by BD. This is the first result obtained. In the same way, if I change my perception to other side, suppose this side of the part, this another side, that means yes, this side. Okay, this is the big triangle that I have here, B, D, C, and small triangle. Can you observe that small triangle like this? Okay, B, Q, P. Again, these two triangles are so similar. Similarly, triangle BDC is similar to triangle BQP. So these two triangles are similar on the same lines. Angle similarity. You can notice that. Also by AA similarity. So what can I conclude again? Okay, this was given as Y and this was given as Z. So again, if I take Z by Y, corresponding sides are in the same ratio. Z by Y is equal to BQ by again BD, if you notice. This is second result. Right? Likewise, we obtain two results. What are those? Z by X is equal to QD by BD and Z by x is equal to QD by BD, and Z by y is equal to BQ by BD. Add both. Z by x plus Z by y is equal to QD by BD plus BQ by BD. Okay, right, you have a Z common, take it out. 1 by x plus 1 by y is equal to, okay, denominator is same, BD. So QD plus BD. What is QD plus BD? That means this QD plus BQ. In fact, I should write QD plus BQ. What is QD plus BQ? If you add these two parts, you'll get BD. So BD by BD, that is equal to 1. So Z into 1 by x plus 1 by y, we got 1. Bring this Z to this side. So 1 by x plus 1 by y is equal to 1 by Z. That is the desired result. So take this question. You may get for 4 marks or 8 marks, or sometimes as a part of a big question. So learn it thoroughly. Another question. A flagpole of 4 meter tall casts 6 meter shadow, and at the same time nearby building casts a shadow of 24 meters. How tall is the building? Right, we have a flagpole. Suppose this is a flagpole AB. Don't worry, it is straight, feel it, and it's shadow. This is, suppose this is shadow, that means it's 6 meters shadow. This is 4 meters. So join like this. Sun rays are falling like this, okay, shadow. And now at the same time nearby building casts 24 meters shadow. So what would be the height of the building? That's what he's asking. Suppose PQ is the building and QR is its shadow. Right, all those things. Suppose AB is a flagpole, its height is equal to 4, BC is its shadow 6 meters, and PQ is actual height of the building, and QR its shadow. All these things you write on your own. Now in triangle ABC and triangle PQR, we have angle B is equal to angle Q. Angles at B is equal to angle at Q. Don't they are equal, because yes, whether it is a flagpole or a building, it stand upwards in a right angle manner. And at the same time, angle of incidence is also same, because he has used the word at the same time. So angle of incidence also same. Angle C is equal to angle R. Angle of incidence, angle of incidence, angle, right angle. This is right angle. So 2 angles are enough, because third angle will automatically equal. Therefore, by AAA similarity criteria, triangle ABC is similar to triangle PQR. So the immediate consequence is, when similarity is established, sides are in proportion. That's why you can take PQ by AB is equal to PQ. That's what we want. PQ by AB is equal to RQ by BC or CB, whatever. RQ by CB, that is PQ by 4 is equal to 24 by 6, right? So PQ by 4 is equal to 4, because it's 6 fours. Therefore PQ, that is building's length, height, original height is 16 meters. Look at the units, it's 16 meters. Thus you can answer this question, right? So similarity is the central theme of many questions what we are discussing here. So establish similarity by producing some evidences and then compare the respective sides. Okay children, let me do the last question for this session. In fact, we have so many questions left, but time doesn't permit all to do all those things, right? Okay, here AX and DY are altitudes of 2 similar triangles, ABC and DF. Prove that AX is to DY is equal to AB is to DE. Okay, here we have 2 triangles mind you, they are similar triangles. It was given like that. Suppose this is ABC, and this is let me show you in a different yes, this is DEF. These are the two triangles that were given. Okay, now what happens, what was given is AX is the altitude and dy is the altitude of this triangle. So these are the altitudes. Mind you, altitude means they're nothing but at right angles, heights. So these are the right angles. Okay, here what we have to prove is AX is to dy is equal to AB is to DE. Okay, let me show you two triangles here. The triangle that has been shaded here and this triangle. I want to compare those two triangles. Triangle ABX and triangle DEY. In triangle ABX and triangle DEY, I am seeking for similar features. Of course, here see angle B is equal to angle E, obviously, because why angle B is equal to angle E? Because since triangle ABC is similar to triangle DEF. Both triangles are similar in nature. That's why this corresponding angle and corresponding angle to B is E, and both are equal. Okay, keep it aside. And also, as we noticed, there is a right angle in both, that is angle AXB, because it is altitude. AX is altitude, dy and also dy is also angle AX, also altitude. So angle AXB is equal to angle dy is equal to 90 degrees. This is altitude. Okay, yes, two angles are equal, automatically third angle will also be equal. That means by a similarity criteria, a similarity, what I can tell is triangle ABX is similar to triangle DEY. Okay, what is the immediate consequence of similarity of triangles? We compare the sides. That means the corresponding sides are in the same ratio. So AX by dy, that means a side's ratio has been taken. So and comparing with another, AB by DE must be equal to AB by DE. Therefore, AX is to DY is equal to, don't we write like this, AB is to DE. That's it. Likewise, you can conclude this question. So thank you, friends. Hope you enjoyed all these questions. These are not enough, of course. You need to do a lot more practice, and to obtain good score or good confidence, you have to keep practicing, right? Thank you very much for watching all these, and support, share and subscribe my channel. You can call me if you have any doubts. This is my phone number, and I can be in touch. I can be in touch at any time that you may ask me, right? Okay, thank you once again, and bye for now.